Welcome to this webinar on the SP Series self-priming magnetic drive sealless centrifugal pumps. If you have any additional questions after this presentation, you can contact Finnish Thompson using our website contact form at www.finishthompson.com or calling 1-800-934-9384. This is the SP Series family curve, which shows the performance range of the SP line. We have 4 pumps in the SP family. The red curve is our smallest 1" by 1" SP pump, the SP10. The light blue and purple curves represent the SP11 and SP15, which are both 1.5" pumps. The largest dark blue curve is the SP22, which can handle up to approximately 200 gallons per minute, or 45 meters cubed per hour, and is available as a 2" by 2" pump or a 3" by 2" flange connection. The SP22 is commonly used for rail cars or other high-flow applications. The SP Series is a self-priming pump which uses a gooseneck design to trap liquid inside the housing when the pump is turned off. That liquid is used to create a liquid ring vacuum that allows atmospheric pressure to push the fluid up from its container, and then functions as a standard centrifugal pump after priming is complete. The SP is capable of lifting fluids from as deep as 25 feet or 7.6 meters below the pump. This deep priming ability allows flexibility in lifting fluids with specific gravities greater than 1.0. The following diagrams show the priming system at work. The pump is first primed during installation through a fill port or backfilled through the pipe system. Diagram 2 depicts the pump first cycling and a liquid ring is created around the impeller and the inner volute. This causes a low pressure area on the intake side and liquid begins pushing up into the housing. In diagram 3, the liquid has fully flooded the housing and all the air has escaped through the discharge pipe. The pump now acts like a traditional centrifugal pump. In diagram 4, after the pump has been turned off, a gooseneck prevents all of the liquid from backflowing through the pump, and enough liquid is retained in the housing to reprime the pump the next time it is turned on. It can be helpful to see this priming sequence in action. We start by initially priming the pump during installation through the fill plug. Once the pump is activated, you can see the liquid ring formed in the middle of the housing. The vacuum created by the liquid ring then pushes liquid up through the intake piping. After the pump is primed, it continues operating as a traditional flooded suction centrifugal pump. After the pump is shut off, you can see some of the liquid travel back through the piping, but enough liquid is retained by the gooseneck and the pump is primed and ready to go. The gooseneck design is the key to the SP pump's ability to stay primed. The arrow on the top shows the fluid enters the pump above the eye of the impeller. So when the pump is stopped, the fluid travels back up through the gooseneck until the fluid level reaches the impeller and then stops. An inner volute O-ring creates a tight air seal and eliminates the need for an external foot valve or an internal check valve, which can be points of failure. The casing contains a drain and fill plug. The fill port is used for a first initial prime during installation of the pump, and the drain plug is used to remove fluid from the pump housing before maintenance or servicing. Both plugs have a straight cylindrical thread that is hand-tightened and sealed with an O-ring. It is recommended to only use the supplied fill plug, as tapered fittings can add pressure to the housing at these points and potentially damage the pump. The SP pump has a very fast priming time and can lift fluid from 18 feet in less than 90 seconds, and often is less than 30 seconds for short distances under 6 feet or 1.8 meters. Being powered by an electric motor also makes the SP an economical and efficient option compared to air-powered pumps. Here are 2 examples of installation. The right image depicts the SP being used to move fluid from a storage tank to a small day tank or container. Importantly, there is no pipe obstruction on the discharge side of the pump, so the pump can successfully prime by moving air from the suction side to the discharge side until the pump is filled with liquid. The left installation shows a yellow check valve on the discharge section of the pipe system. The check valve prevents air from escaping, so in this installation example, an air vent line is required for the pump to successfully prime. It is atmospheric pressure that pushes the fluid up the suction pipe into the pump. Total suction lift, including pipe friction loss and corrections for specific gravity and altitude, must not exceed 25 feet or 7.6 meters. There are some circumstances that require the maximum lift to be adjusted. Altitude is very important to the capabilities of a self-priming pump. At higher altitudes, atmospheric pressure is reduced. Thus, maximum lift is reduced by 1 foot or 3.4 meters for every 1,000 feet or 304 meters of altitude. The specific gravity of the fluid being pumped also affects the maximum lift for fluids heavier than water. To calculate, divide 25 feet by the specific gravity. For example, when pumping hydrochloric acid, which has a specific gravity of 1.18, you would divide 25 feet by 1.18 for a maximum adjusted lift of about 21 feet. The calculations mentioned on the last slide are important to know where to install the pump relative to your application. For pumps installed below the liquid level, flooded suction performance curves can be used as the pump behaves the same as the traditional flooded suction centrifugal pump after the pump is primed. SP Series curves are available for flooded suction, 5 feet or 1.5 meters, 10 feet or 3 meters, and 15 feet or 4.6 meters of lift. For lifts above 15 feet, 4.6 meters, consult the FTI sales team. Note that both pipe length and pipe diameter affect how long it takes a pump to prime. So when using larger pipe diameters for peak flow performance, take the additional priming time into consideration. Estimated priming times can be found in the SP Series Performance Curve book found on our website. SP Series pumps are great at handling small amounts of entrained air as they can discharge it through the piping system. However, amounts of entrained air greater than approximately 10% can cause the pump to temporarily lose prime, which results in a continuous pumping and repriming cycle. In this scenario, you may wish to relocate the suction piping to a location where less air enters the system. Do not pump flammable or combustible liquids with the SP Series. The pumps can be used to pump non-flammable or non-combustible liquids in a hazardous location when equipped with certain options like explosion-proof motors and bronze bump rings. Contact Thompson Sales for more information about the use of SP Series pumps in hazardous locations. SP pumps are not designed for liquids with solids. The maximum solid size is 100 micron for slurries and 1/64th inch or 0.4 millimeters for infrequent particles. An example of an application where solids could inadvertently enter the pump is a sump application near a concrete floor which could accumulate grit. If solids are present, we recommend using silicon carbide, which is a harder shaft and bearing material. If you have solids in your application, we recommend the use of a basket strainer. For general purpose applications, a 1/16th inch or 1 to 3 millimeter perforation basket strainer can be used but requires regular inspections. Adjust the perforation size of your basket strainers accordingly if required by the application. For truck and rail applications, we have a convenient, ready-to-install pump assemblies with basket strainers, bases, and motors available directly from Thompson. Thompson also has standard base plates available in fiberglass and stainless steel, which makes installation easier and gives the pump a raised platform to help avoid standing water or chemicals. This can help avoid maintenance issues due to the standing liquid with the pump or motor. One method of unloading liquid from rail cars or tanker trucks involves introducing pressurized air on top of the liquid, which forces the liquid out of the discharge valve. At the bottom of the cycle, the pumps are allowed to gurgle to take up all the potential acid or liquid at the bottom of the rail car. The SP is considerably more efficient than traditional air-powered systems. SP pumps are also ideal for double containment tanks where they are able to empty the tanks over retaining walls. This eliminates the need for bulkhead fittings, which can lead to leaks. In surface finishing applications, the SP Series pump can replace vertical pumps submerged in the fluid. This allows the pump to be installed in a safer position away from the liquid being pumped for easy maintenance access. It also allows liquid to be pulled from the top of the tank instead of having a bulkhead fitting below the liquid level in the tank, which can lead to unsafe leaks. SP pumps can also be mounted in parallel, but should have independent suction lines. This allows pumps to be operated 1, 2, or more at a time. The air bleed line runs back into the tank for safety, but connects above the pump to allow it to properly bleed air, allowing priming. In this scenario, pumps are installed in parallel, but with common suction and discharge piping. The second pump in this scenario would be a standby pump that would be available while the other pump is under maintenance. The SP Series has a variety of electric motor options which fit standard NEMA or IEC motors, including TEFC, chemical duty, washdown, explosion-proof, and there are even air motor-driven options as well. Gas engines are also available for remote or mobile vehicle use. The SP Series self-priming mag drive centrifugal pump is one of the most innovative and versatile pumps in our lineup. Big on power while still being energy efficient. Deep lift capabilities of up to 25 feet and lightning fast priming make the SP perfect for transferring from the top of rail cars or bulk storage or day tanks, pumping from underground sumps or pits, moving liquid from surface finishing tanks through filters, and more applications. The sealless design has no leaks and no need for seal replacements, and corrosion-resistant materials help handle the most difficult and harsh applications. For more information, visit our website at www.finishthompson.com. Thank you.